Model View Controller is a central tenet of the Spring MVC framework. Because MVC is such a central part of Spring MVC, we're going to have a discussion regarding why MVC exists and the benefits that it provides to us. So let's begin talking about the MVC pattern. MVC is debatable in the fact that it can be considered a pattern, an architecture approach. Some say it's a principle. Others just say it's kind of a technique that you use. So you can call it whatever you would like, but it comes down to the point that we separate our systems into three main components. And that's the model, the view, and the controller. And that's where we get the name and the MVC acronym. So let's discuss these three parts of the system. MVC says we have a model, and a model represents the objects within our system. So we know we have to store data within an application. For example, for a library application, we may need to know the book and the author. Those would be objects within our object model, and they would represent a model for us because they're objects that hold the information we will be working with throughout our application. Now, sometimes it's debatable as to whether the model mimics the database tables or whether it can be just some custom object we have built to support our application. Moving on, the next piece of MVC is the view. And views are pretty simple. You see them all the time. It's just that user interface that you work with an application. So with a web application, we are building a web page. And that web page usually takes some pieces of the model, the information the system uses, and it displays them to our end users. Now between the model and the view is the controller. And the controller is what performs all of our application logic. It's what makes the system work. It's all of the different actions that we can perform within an application. So for example, maybe we issue a request against a web server for a particular URL, and we pass some data back, and the controller is the piece that will actually save that data. So you can call MVC anything you would like, a pattern, a principle, some architecture, but it all boils down to this paradigm where we say that we are going to divide our system into a model, a view, and a controller. These three separate components, and we're going to do our best not to mix one component with another. So let's talk a little bit about how MVC originated. MVC is not a concept that was brought up strictly for web applications. MVC was actually first termed in 1978. So all sorts of systems outside of web applications have experienced this problem where the view, the model, and the controller intermingle within code. And this creates code that is hard to read, hard to maintain, and hard to understand. MVC has really been adopted by a lot of web application developers, especially Java developers, because we at one point often used scriptlets within our code. So on the image on the left, you will see that we have a scriptlet displayed within a JSP page. And this is a fairly tame example, but this is exactly what we are trying to avoid. People were placing all sorts of logic within the view. They were creating database connections within the view. They were performing business logic within the view. And this made the code harder to read, and it made the code less reusable. So when applications mixed code that spanned all three of these layers, we had this mess, and some people referred to it as a ball of mud or spaghetti code. And it was very hard to follow, and if you hit an application that was coded in this approach, it was not enjoyable to work within it. For our purposes, we are looking to apply the MVC pattern to Java web applications. So someone will access our web page via their browser, and they're going to send a request to our server, which hosts our Java web application. Once we receive that request, we are going to route the request basically through the MVC pattern and then return a response. So let's drill down and take a closer look at the MVC portion of this diagram. So when we think about it, we need to look at the model. And the model is basically going to have the information that we use within our system stored in objects. And here you see we have a ER diagram for an application user, and then we also have a class from Eclipse, where we have a user class. And we see that we have a field for each database column. And this is debatable. Like I said, some people say the model should mimic your database tables. Others will say there should be kind of a middle layer in between that. Either way works. It's all that concept of the model. There is a lot of debate about MVC. Now, you'll notice next, if we look to the right, I have included the controller as opposed to the view. And that's because the controller often conducts the interactions between the model and the view. Here we see that we are getting the user information from the view, and then we're updating the user profile. So maybe that is updating our model and then storing that information in a database. And then we're creating an invoice. So maybe we take that user model object and we pass it into a method that can then send an invoice to that user based upon their address. And then finally, we have the view on the right side of our diagram here. And this is basically the user interface that's going to collect the information from our user. And you can see how it represents the different fields in the model. We have the first name, the last name, and a birth date and a profile picture. So you can see how the controller kind of orchestrates that interaction between the model and the view, but how each layer remains separate from the other. For example, we could replace our view with, let's say, a RESTful web service, and that RESTful web service could call our controller. So there's separation there that creates reusability for us. So let's continue our discussion of the benefits of MVC. So as we alluded to, MVC reduces coupling within our applications, and it also reduces dependencies between components. This allows the components to be used independently. So for example, an object in the model can be used in multiple views, or it can be used in multiple controllers because it does not have view information or business logic embedded within it. This is great for when you have multiple views. So for example, maybe I want to display some information in an HTML table, but I also want to make it available via Excel. Well, I can use the same model to render both those outputs. And since the model knows nothing about the controller or the view, it's agnostic and it does not have any code changes that need to be made to that model component. The only thing we have to do is write a new view. Another great feature of MVC is that it's going to establish a predictable architecture for your applications. You're going to be able to look at an application, and once you understand how the MVC paradigm is applied, you'll be able to predict how requests are going to flow through the application and how the business logic is going to be processed and eventually a response rendered to the client. And once you apply something like a framework like Spring MVC, this becomes true of a portfolio of applications because they all handle request processing using the MVC approach. And the final benefit is that you're not going to be mixing different concerns within your code. When you're looking at your view layer, you're only going to be looking at JSP and HTML tags. You're not going to see a bunch of scriptlets and Java code embedded within your JSP. This can make the code very hard to read, and it can be very hard to follow the logic of the application as well as extend the application and make modifications. It really increases your maintenance costs when you have all of the 3 layers of MVC combined. So that's why we separate them out when we build our applications.